Hello everybody and welcome back to Maths Miss Buick. In this video we're focusing on the conjugate root theorem and also finding other roots of cubic expressions given one root already. So let's begin by looking at the conjugate root theorem. So if z is a root of az to the power of n plus bzn minus 1 plus plus dz plus c, where a, b, c and d are an element of R, which are the real numbers, then z bar is also a root of this equation. Now, z bar represents the conjugate, and I have a video explaining conjugates if you would like to watch that video before you look at this video. So we're going to use this conjugate root theorem down in our example here to further explain what it actually is. So we have minus 2 plus 2i is a root of this cubic here. Find the other two roots. Well, the conjugate root theorem tells us that the conjugate of this root here is also a root of this cubic here if the numbers a, b, c and d are numbers which are real numbers. And in this case here, a would be 1, b would be 3, c would be 4, and of course this d down here, or some constant, is minus 8, and of course minus 8, 4, 3 and 1 are all elements of the real numbers. So we can say straight away that the conjugate of this here is also a root. So for example, we have z1 is minus 2 plus 2i, so we can deduct another root straight away, which is the conjugate of this one, which is minus 2 minus 2i, because we simply change the sign to the opposite sign in the centre between the a, which is the real, and the b, which is the imaginary. Now we need to find out what is the third root. We're looking for 3 roots because we can see the highest power on our cubic here is a 3. So to begin that, we're going to firstly start off by forming a quadratic equation with these 2 roots here. So let's recall z squared minus the sum of z plus the product equals 0. I have a video explaining this in more detail as well, so it'll be underneath how to form a quadratic given 2 roots already. So let's begin by finding the sum of our 2 complex numbers and then getting the product of our 2 complex numbers. So the sum, well, here we have our 2 complex numbers and we're adding them together. So the rule is we add the real with the real. So in this situation here, the real, of course, are always numbers without the I, so they're the real. And our imaginaries are the ones with the i's. Okay, so let's add our real numbers. So we have minus 2 is minus 4, negative 4, and 2i minus 2i, of course, is 0. So the sum is negative 4. Now our product will be, let's multiply our numbers together. Okay, so we have negative 2 by negative 2 is positive 4. Negative 2 by negative 2i is positive 4i. Plus 2i minus 2 is negative 4i. And then 2i by negative 2i is negative 4i. And we square. And don't forget that I squared is equal to negative 1. And you're told that in the exam paper. So you can see here that the 2 4i's cancel out. And we're left with 4. Now don't forget this here goes to a negative. So let's replace the I squared with the minus 1. This goes to a plus, so we get 8. So when we fill that in, we have z squared minus the sum. So don't forget now it's minus and a minus, which is a plus 4z plus 8 equals 0. This here is our quadratic which we have formed. Now, we're going to take that lovely quadratic and we're going to now divide it into our cubic equation. So let's write that out. So we have z squared plus 4z plus 8, and we're long dividing that into z cubed plus 3z squared plus 4z minus 8. Okay, so let's go. So Z squared divides into Z cubed, well, a remainder of Z. Z by Z squared is Z cubed. Z by 4Z is 4Z squared. And then Z by 8 is 8Z. So we'll put a line across and we'll now change to our opposite signs. So you can see here that the Z cubes cancel out. 3Z squared minus 4Z squared is minus 1Z squared. 4Z minus 8Z is minus 4Z. And we bring down with us now a negative 8. And we start again. Z squared divides into minus Z squared minus 1 time. Minus 1 is now multiplied by this row here. So minus 1 by Z squared is minus Z squared. Minus 1 by 4Z is minus 4Z. And minus 1 by 8 is minus 8. Let's change our signs, and we can see when we do that, it all cancels out and it comes down to be a 0. Now, a common mistake here is that often students think that Z minus 1 is the root. However, Z minus 1 is the factor. So we're going to transform this into a root. Let's equal it to 0 and we'll solve. So it implies that Z is equal to 1 plus 0i. So when you bring over the negative 1, this side it comes positive like over here. So this is our third root. So we have called that Z3. So to recap, Z1 was the root we were given in the question. So minus 2 plus 2i. Z2 is the conjugate of this, and we know it's the conjugate because the numbers or the coefficients in front of our z's are all real numbers. So minus 2 minus 2i, and then our Z3 is as above 1 plus 0i. So here are our 3 roots from the conjugate root theorem and our cubic equation.